Addition method. Line the equations up in the form ax plus by equals c. You will add the equations vertically. The goal is to have one of the variables cancel out. A variable will cancel out when the coefficients are the same number and opposite in sign. You may have to multiply one or both equations to make this happen. If both variables drop out, same as in substitution method, the numbers left do not equal their parallel lines, no solution. If the numbers left equal, they're the same line or infinite solution. Then you want to substitute the number into either equation for the solution if you get an answer from up here. So, as an example, x plus 4y equals minus 10 minus x minus 3y equals 9. First, they're all in the correct form. The x, the y, the coefficient. If they were not in this form, I would have to reorganize the equations. So here my x's already have the same number and opposite sign, so I'm all set. So if I look here, this is a 1, this is a minus 1. These are all set. I don't have to do anything to this. So I just rewrote them, and now I'm going to add them vertically. So notice I'm going down here. So x take away x is 0. 4 take away 3 is a 1. Minus 10 plus a 9 is a minus 1. So 0 plus y is a minus 1. Y equals minus 1. So I got one of my answers right here. So now I'm going to take that and I'm going to plug it into the first equation. So I rewrote the first equation, x plus 4y equals minus 10. I could use either equation, it does not matter. So x plus 4 times minus 1, I used a minus 1 because that's what y is. So x minus 4 equals minus 10. Add 4 to both sides. X equals minus 6. Finally, the solution, negative 6, negative 1. Let's try another one. These are all the same problems we did with the substitution. I'm just doing them now with addition. 2x, negative y equals negative 13. X minus 2y equals 9. We want the x's to drop out, so I'm going to multiply the bottom equation by a 2. Again, I'm picking a 2 because the top one has a negative 2. So this has to be a positive 2 in order to add this up to make it a 0. So I rewrote the second equation right here, and I'm just going to multiply everything by a positive 2. So I get a 2 times x is a 2x, 2 times minus 2y is a minus 4y, 2 times 9 is an 18. Make sure you do all three terms. All right, rewrite it. So here's my first equation rewritten, and now this is my new second equation right here. And notice when I add vertically, minus 2 plus 2, that gives me my 0. A minus 1 minus a 4 is a minus 5y, and negative 13 plus 18 is 5. So I get 0 minus 5y is a 5, minus 5y is 5. Divide by minus 5 both sides, so you get y is a minus 1. Take your minus 1, and I happen to put it into the second equation. Again, it doesn't matter. So the second equation was x minus 2y equals 9. Substituting the minus 1 for y, I get x minus 2 times minus 1 is 9. X plus 2 is 9, so negative 2 times negative 1 is a positive 2. Subtract 2, so I get x is a 7. Again, my solution is in the form of xy, so I get 7, negative 1. On this problem here, 8a plus 2b equals 18. 4a minus 3b equals minus 15. I'm going to choose to get rid of my b's just to show you how you can multiply both equations to get rid of them. So it's kind of like common denominator. I need to make these a 6. I need to make this top one a positive 6, and I'll make the bottom one a negative 6. So in order to do that, I'm going to multiply the top equation by 3, right? So that's going to give me a positive 6. And I'm going to multiply the bottom equation by 2. That's going to make this a negative 6. This will force the b's to drop out. So the top equation is right here, multiplying by 3. So I get 3 times 8 is 24a, 3 times 2 is positive 6b, 3 times 18 is a 54. This is my second equation here multiplied by 2. So 2 times 4 is 8a. 2 times the negative 3b is negative 6b. 2 times negative 15 is negative 30. Now I'm going to add them vertically. So 24 plus 8 is 32. Notice my b's drop out. 54 take away 30 is 24. So I have 32a equals 24. Divide by 32, so I get a is 24 32nds, or simplifying it is a 3/4. Now I decided to plug this into my second equation. 4a minus 3b equals minus 15. Again, it's purely random. You can pick either equation. So it's going to be 4 times 3/4 minus 3b equals minus 15. So it's 12 over 4, right? 4 times 3 is 12 over 4. So that's a 3 here. So 3 minus 3b equals minus 15. Subtract 3. I get minus 3b equals minus 18. Divide by negative 3. Finally, I get b is a 6. So the solution for a comma b is 3/4 and a 6. Let's look at the ones that don't work. X minus y equals 6. 3x minus 3y equals 10. I want my x's to drop out. So this top number here has to be a negative 3. So I'm going to multiply the first equation by negative 3. So negative 3 times x is negative 3x. Negative 3 times y is plus 3y. Negative 3 times 6 is negative 18. I rewrote the second equation. And then when I get to this point and I go to add them vertically, yeah, my x's dropped out. But whoa, my y's dropped out too. And this one gave me a number, negative 8. So what I got was a 0 equals a negative 8, which makes no sense. But when you're solving these, that means it's a parallel line, there's no solution, or it's inconsistent. Let's try the one that has the same line. So the 9x plus 6y equals 15, minus 3x minus 2y equals minus 5. So I'm going to multiply the second equation by 3, because I'm going to try to make it a negative 9, so it will drop out with a positive 9. So here is the second equation. 3 times negative 3 is negative 9x. 3 times negative 2 is negative 6x. 3 times negative 5 is negative 15. So this is the rewriting of my first equation. This is my new second equation that I got from here. And as I add them vertically, 9 take away 9 is 0. 6 take away 6 is 0. 15 take away 15 is 0. So this one is 0 equals 0. That means it's the same line. Infinite solutions, so they're consistent and dependent.